This is the fourth MES 2 online class for the student of class 10 Beren Baptist Academy. And in today's class, we are going to start a new chapter, which is chapter 11, Coordinate Geometry. Actually, this is the continuation of class 9 coordinate geometry, but I'm sure you did not learn about this chapter in class 9. Anyway, I will tell you some of the basic part of this chapter. So in this chapter is all about a coordinate plane. Now you can see here two axes are drawn. At least you may be familiar with this axis. You have done a graph in class 9. The horizontal axis, which goes from left to right or right to left, this axis is called x-axis, and the vertical axis, which is from top to bottom or bottom to top, is called y-axis. And these two axes intersect each other at one point, and this point is called origin, and these two axes are perpendicular. That means this angle is 90 degree. Then you can see here are some of the definitions, or you can say some of the points that will help you to understand better about this chapter. The horizontal axis is called x-axis and vertical axis is called y-axis. Noted here there are two terms. The first one is abscissa, and another name for this abscissa is x-coordinate. This is nothing but the distance of a point from y-axis, and it is denoted by x. And the second term is ordinate, or another term for this ordinate is y-coordinate. This is the distance of a point from x-axis. It is denoted by y. Now let's try to understand these two terms here in our figure. In the figure, you can see here I take a point P. Here P is a point, and now let's see how far is this point P from y-axis. Here is y-axis, and this is point P. Now the distance of this point P from y-axis is nothing but this one. This is a distance. So this distance is called abscissa. I repeat, the distance of a point from y-axis is called abscissa, and just now you have seen abscissa is denoted by letter x. So abscissa is nothing but distance of any point. Here in this case, point is P. How far is point P from y-axis? That distance is called abscissa. Later we have ordinate. There is nothing but the distance of this point P from x-axis. Here is x-axis, and this gives distance between point this P and x-axis. So this distance is called ordinate, and its ordinate is denoted by letter y. Then now we write this for P. We write x and y together. Abscissa, comma, ordinate y. So this x and y written together, which are abscissa and ordinate, are collectively called coordinate of this point P. Then you can see after abscissa and ordinate, the other pairs x, y. X is nothing but abscissa and y is nothing but ordinate. This other pair written abscissa first, followed by ordinate, and you can see between them is comma. This other pair, this together is called coordinates of a point. So in the figure, the point is here P. So x, y, abscissa and ordinate written together inside brackets, separated them by comma, is the coordinates of point P. Okay, these are some of the basic concept of this chapter. Then moving further, now let's try to understand actually abscissa and ordinate. Here you can see, let's try to understand the meaning of these 2 points. Here meaning of point 5, 3 inside the bracket 5, comma 3. Let's say this is P 5.3, and another point Q minus 4, 1. What is the actual meaning of these 2 points? Again, if you look at the axis, 2 axes, now I'll tell you this the point where two axes intersect is called origin, and here we take 0. Then from this origin toward right side on x-axis we take number 1, 2, 3, 4, 5, 6 like that, which are positive. And from this origin toward left on this x-axis numbers are taken -1, -2, -3, -4, -5 like that. And here -5 is not the last and 6 is not the last here. As you can see, arrowhead, this number will continue in this direction like that. Left side to number will continue as it is indicated by arrowhead. So on x-axis, right side we take plus, left side we take minus. Like that on y-axis, from origin above we take 1, 2, 3, 4 which are plus, and below this origin numbers are taken -1, -2, -3. Then now let's try to look at this. Let's try to understand the meaning of this point 5, 3. The name of this point is P, so here we have taken P, and why here point P is here. Now I'll show you. Now the distance of this point P from y-axis, how far is the distance? You can see there is a distance of point P from y-axis. And what is the distance of this point P from x-axis? We draw another perpendicular here, then we get the distance of this point P from x-axis too. Then the distance of this point P from y-axis, this length, how long is this? It is 1, 2, 3 up to 5, you can see. So this distance is 5, and we use x for abscissa. Now x is 5 like that. For point P, the distance of this point P from x-axis, how long is this distance? You can see here 1, 2 up to 3. So this ordinate denoted by y is 3. Then we will write this point P to be, coordinate of this point P to be, we used to write first this x first, x below is 5, comma, y below here is 3. So now point P, which is 5, 3 is located here, which is 5 units away from y-axis and 3 units away from x-axis. Like that, let's see for another point which is Q -4, 1. Then Q will be here. Why Q is here? You can see the first number which stands for abscissa is -4. Then let's see the distance of this point Q from x-axis and also from y-axis. Now as you can see here, y is how many units away from this y-axis? It is -4. The distance of this point Q from y-axis is -4. So we write this -4, comma. Then how far is this point Q from x-axis? As you can see, this distance, it is 1. So we write -4, 1 for this point Q. This meaning is this point Q is -4 units away from y-axis and 1 unit away from x-axis. Here we use minus because it is in opposite direction of this y-axis. Here we have taken distance of P to be +5 because it is right hand side, and distance of point Q to be taken minus because it is left hand side. So this is how we look at or we plot point on the plane, or the meaning of point where you find two numbers which are abscissa and ordinate. Then now moving to the next topic. Now we are coming to the main topic of this chapter. Here the topic is section formula. This is the new topic or new thing that you are going to learn in class 10, and the name of this formula is section formula. Let's see what is this. The coordinates of the point which divides the line joining the points x1, y1 and x2, y2 in the ratio m:n are mx2 plus nx1 divided by m plus n, comma, next my2 plus ny1 divided by m plus n. So these are the coordinate of point of division. Now let's try to understand the exact meaning of this formula called section formula. For that, here we have two axes, x-axis and y-axis. This is y-axis and this is x-axis. Now we have taken 2 points here, x1, y1, and this second point is x2, y2. So let's join them. Joining them, we will get a line segment. We get a line segment joining 2 points x1 y1 and x2 y2. Now let's say this line segment is divided at one point. Let's say there is a point, and let this point be R, so that the distance from this first point, let's say this is point P, and the second point, let's say there is Q. Then the distance of point P, distance of this point R from P, let's say this distance is M, and like that the distance of R to Q be N. Then what is the actual meaning here? That the first point P is x1 y1. This meaning is this point P is x1 away from y axis and y1 away from x axis. That is the meaning. Like that, this Q is x2 y2. What is that meaning? So this distance is y2, which is the distance of this point Q from x axis, and the distance of the same point Q from y axis is x2. Then now this line segment is divided at point R at the ratio m is to n. That meaning is from P to R length is m, and from R to Q length is, let's say, n. Then now we want to find the coordinate of this point R, which divide PQ, or the line joining x1 y1 and x2 y2 in the ratio m is to n. And the simple meaning is, now what is the distance of this point R from x-axis and y-axis? Let's say the distance of this point R from y-axis is x abscissa, and distance of this point R from x-axis, let's say this is y. Then now we want to know what is x value and y value. That means what is the distance of point R from y-axis, that is x, and the distance of this point R from x-axis, which is y. So now if you want to find this, it is given here in the section formula. Coordinate of this point R, mx2 plus nx1 divided by m plus n. There is the first one, so there is abscissa. That means there is the value of x for point R. Like that, the second part you can see my2 plus ny1 divided by m plus n, which is ordinate. That means there is the value of y for point R. So this formula will help us to find coordinate of the point dividing any line segment. At x1 y1, x2 y2, we write 1 to 2 just to show the difference, because here we have 2 3 points. So the first point we take x1 y1 abscissa ordinate, here 2 abscissa ordinate, so the second point we take x2 and y2, and the middle point, which is R, dividing PQ, we take x and y to be abscissa and ordinate. So now the point this R, which divide line segment PQ in the ratio m is to n, is given by section formula to be mx2 plus nx1 by m plus n, which is abscissa, and my2 plus ny1 divided by m plus n is ordinate. So this is the meaning of this section formula. Now next we will prove this formula. Proving this formula is important. If we look at the previous year board question. But before we start proving of this question, let's look at one of the deduction. The deduction from this section formula is, see, you can see deduction. The coordinates of the midpoint of the line segment joining x1 y1 and x2 y2 are x2 plus x1 by 2 and y2 plus y1 by 2. Now try to understand the meaning of midpoint. Midpoint means middle point. Let's say line segment is PQ, because this is the line segment joining point P and point Q. And let's say the coordinate of point P are x1, y1, and the coordinate of point Q are x2, y2. Then now we want to find coordinate of this point R. Let's say point R is midpoint. That meaning is from P to R length and from R to Q length are equal. That means the value of m and n will be equal, so their ratio will be always 1:1. You may ask why, how? Now let's see m divided by n, which is the ratio of m is to n. If m is 4, then n will also be 4 because r is the midpoint. Then if they are equal, 4 by 4, you can see 1 by 1. That means ratio 1:1. Or now let's take another length for m and n. If m is 5, then n will also be 5. In this case too, 1 by 1, which is 1:1. Or the length of this m and n may be 7 and 7. In this case, we will get 1 by 1. In all the cases, we get ratio 1:1. Why this happened? Because r is the middle point. Then now putting the value of m and n to be 1, 1 in the section formula. In the section formula, you can see mx2, then the value of m will be 1 here, so 1 into x2 we get only x2. Then second, nx1, n value will also be 1, 1 into x1 is also only x1, divided by, you can see m plus n, then m and n are 1 each, so 1 plus 1 is 2. Just like that, putting the value of m and n 1 in this section formula, we get y2 plus y1 divided by 2. So if you want to find the coordinate of the midpoint, then you can directly use this formula, which is x2 plus x1 by 2 and y2 plus y1 by 2. In this case, m value and n value are 1 each. Then now we move to the question. Look at the question. Prove that the coordinates of the point R, which divides the line joining point x1, y1 and q x2, y2 internally in the ratio m is to n r, m x2 plus n x1 divided by m plus n, comma, m y2 plus n y1 divided by m plus n. So this is the question, simply asking to derive the section formula, and this exact question were asked twice in 2010 and 2012, and the same question was also asked in different way in the year 2016 and 2018. So in these 2 years, question was modified and asked in this way: find the coordinates of the point which divides the line joining the point x1, y1 and x2, y2 internally in the ratio m is to n. Actually, this second question is also the same question but asked in different way, and this was exactly asked in this 2016 and 2018. So for both the question, answer will be the same thing. That means we are to derive this section formula. So now let's see how we derive this section formula. Here is the proof. Let x prime ox and y prime oy be the coordinate axis so that O is the origin. Let r xy divides the line joining p x1 y1 and q x2 y2 internally in the ratio m is to n. So here we have taken this x prime ox to be x-axis, y prime oy to be y-axis, and these two axes intersect at this O. The origin here is O. Then let's continue. And the point that divides the line segment PQBR, that means from P to R is M and from R to Q is N. So this must we have written here in the first paragraph. Then now the second one, PA, QB and RC are drawn perpendicular to x-axis. Now this is something like construction. Let's do this. PA. So now from P to draw a perpendicular on x-axis. PA, this is perpendicular. Then QB, this is also perpendicular, there is B, and RC. So we have drawn here three perpendiculars from P, Q and R on x-axis. Then let's continue reading. PD perpendicular to RC. Here you can see RC and you can see P. So we draw PD. PD. This is point D and this is a perpendicular. Like that, RE is perpendicular to QB are also drawn. RE perpendicular to QB. Here we have QB. Here we have R. So we will start from R. There is point E. This is also perpendicular. Then we get two right triangles here. You can see here we have two right triangles. Now we will prove that they are similar. Now actually this similarity of triangle you don't learn yet, but actually you will learn in chapter 7 of this class 10 syllabus. Anyway, for this just I'll tell you about one theorem. Now we'll try to make these two triangles similar. The triangle are PDR and REQ. So to make them similar we need some criteria. And now let's see in these two triangles what are the equal angles that we see. Here we can see this angle D is 90 and angle E is also 90. So we can say in these two triangles two angles are equal. Here we have angle PDR, which is PDR, this angle D, and REQ which is angle E. They are equal, they're 98. And again if you look here, another two angles are also equal. They are PRD, this angle and this angle. Why they are equal? Now you can see RB and RC are perpendicular. Sorry, they are parallel. And for these two parallel sides, you can take PQ to be transversal. Then these two angles are nothing but their corresponding angle. Remember, according to one of the theorem you learned in class 9, if two parallel lines are intersected by a transversal, corresponding angle are equal. So now these two angles are corresponding angle, being corresponding angle. And one of the theorem of similarity says if two angles of two triangles are equal, here you can see in this two triangle we can see two angles are equal, then these two triangles are similar. So therefore triangle PDR is similar to triangle REQ by double A similarity. Why we use double A here? Double A stands for angle. And you have seen in that two triangles, in these two triangles two angles are equal, so we use double A similarity to say that they are similar. And another important point about similarity of triangle is once two triangles are similar, their corresponding sides are equal. The ratio of their corresponding sides are equal. That meaning is, now let's see again in this two triangle, what is the corresponding size of PR? This is size of first triangle. Here for the second triangle, what is the corresponding size of PR? Corresponding size is RQ. So we write PR divided by RQ is equal to, we take another size PD. So PD is corresponding size is RE. Like that, for RD corresponding size is QE. So we simply write this ratio are equal. This is one of the property of similar triangle. If two triangles are similar, this is the sign of similarity. The ratio of the corresponding sides are equal. So we have written this. Then now in the next step, this is one of the most important step here. If you look at the figure again, PR and RQ. PR value is M, RQ value is N. So we write M by N here is equal to, now next PD. How we write PD? Now let's look at the figure again. PD. Here is P, here is D. Now we want to write for the line segment PD. How will we do this? PD. Now you know here PD will be equal to AC. You can see PD length will be equal to AC. And here you can see for P it is x1. That means from this O to A is x1 length. This length is x1, and like that for R we have taken xy. So for this R, from this O to C is x. Like that for this point Q it is x2. From this O to Q is x2. Then now how will you write PD? PD is nothing but AC. So we can write this AC to be OC minus OA. I repeat, we can write AC to be OC minus OA. So OC length is x and OA length is x1. Then if we subtract x1 from x, we get this AC, which is PD. So if you look at the step, you can see PD is written as x minus x1. Again, I repeat here, x is from this origin to this C, and x1 is from O to A. So if we remove this x1 from x, we get AC. Like that, the second one we have RE. And let's see RE. Here is R, here is E. RE can be written as OB minus OC. If we remove OC from OB, we get CB or BC, which is equal to RE. So we write this RE as x2 from O to B minus from O to C, that is x. x2 minus x. You can see RE is written as x2 minus x. Like that, now we'll write for RD. Again, let's go back to the figure RD. Here is R, here is D. And again, let's see, from C to R is y, because the distance of this point R from x-axis is y. Like that, the distance of this point R from y-axis is equal to OC. You know OC length is x. But now we have to write for only RD. Then we take only ordinate. So RD can be written as, this meaning is from C to R, distance is y, and from C to D is equal to A to P. This length is y1. So from here to here is y, and from here to here is y1. Then how will you write RD? Y minus y1. So you can see RD is written as y minus y1. And like that, for QE, we can write this QB minus BE. So QB is y2 and BE is equal to RC, which is y. So we can write this QE as y2 minus y. As you can see here, QE is written y2 minus y. Then now we have three expressions to be equal here. M by n, x minus x1 by x2 minus x, and y minus y1 by y2 minus y. Now we will take only two. They're considering m by n is equal to x minus x1 divided by x2 minus x. I mean, we consider this 2. Here cross multiplying. Y is multiplying with x minus x1 and m is multiplying with x2 minus x. Then you can see, now we multiply this n into x, n into x1, then m into x2, m into x. Then now let's write the terms having x left hand side. Here we bring mx from right to left, so ms minus become plus. Here left side we have nx, it is plus, and now we transfer this nx1 to right side. Then nx1, which is minus in left, become plus in right hand side. Then in left hand side you can see from these two terms, you can see x, so we take x common, then m plus n is left here. Right hand side no change. Now we want to express or want to find for only x, so x below is, now send away m plus n to right side. Since x and m plus n together are multiplying here left side, m plus n becomes divide right hand side. So finally we get x below to be mx2 plus nx1 divided by m plus n. So there is x below. Again, now let's go back to the beginning. What is actually x? You can see here we have written, let rxy devise the line joining. That means x is the coordinate, abscissa of point R, and we have to find y2, which is ordinate of point R. Now we get x, which is mx2 plus nx1 divided by m plus n. Now to find y, how do we get x? Let's see. We get x below by equating m by n and x minus x1 by x2 minus x. Then in order to get now y, we will equate m is by n with y minus y1 by y2 minus y. Now let's see. Then considering in the same manner, considering m by n is equal to y minus y1 divided by y2 minus y, we can write y is equal to mx y2 plus n y1 divided by m plus n. Yeah, without calculation you can simply get it. How? Let's see. In case of x, we get x is equal to mx2. The only difference here is in place of x it is now y, in place of x1 it is y1, in place of x2 it is y2, in place of x it is y. So we can simply replace x by y and y by x1 by y1, x2 by y2. Then in case of x we can see mx2, then for y it will be my2, then nx1, in that place it will be ny1, m plus n, same thing. So we don't need to calculate again to get this y. We can simply get this relation. Then now we get both x and y, so let's combine them to get coordinate. Y is ordinate and x is abscissa. It is only the conclusion is left now. Thus the coordinate of the point are which divides the joint of p x1 y1 and q x2 y2 internally in the ratio m is to n are mx2 plus nx1 divided by m plus n and m y2 plus n y1 divided by m plus n. So that is how we prove this section formula. And as you can see, there are two different ways asking the same question. So since it is the new chapter, you may find it a little bit hard to understand everything, but I suggest you to repeat watching video again and again until you clear the concept of this chapter. So that's all for today. We will continue in the next class.